I can't think of a worse way to spend an evening than to have to deal with these particular word problems. They test your ability at Math 10 stuff, like dealing with radicals and things that no doubt you've long forgotten. But let's take a little stab at the first one here. Insert two geometric means between A and B. Well, we know what that looks like. That's going to look like A, and then something, and then something, and then B. And there is our two geometric means in there, which means that this is a geometric sequence, which means that it follows this. Our only formula for this entire section. Now, given that, though, we know some of this, but not all of it. We know that the AN, or the last term there, that's also known as B, and we know that the first term is known as A, and we know that R to the n minus 1, well, if that's the last term, it's the fourth term there, so it must be R cubed. And what we're going to be after here is trying to define these two things in terms of A's and B's. Now, to do that, we have to solve this, and what are we going to do? Divide both sides by A, and you get B over A equals R cubed, and then comes the Math 10 terror. We cube root it all, B over A equals R, but we all know that you can't have a radical on the bottom, so we multiply this by A squared over A squared, and in so doing, it looks like this, cube root of A squared B over A cubed equals R. And we're allowed to do this, and remember this from Math 10, cube root of A squared B over the cube root of A cubed. These two things are the same. If you want proof of that, do this. Cube root of 27 over 8 equals the cube root of 27 over the cube root of 8. See if that's true. I know it's not easy. Okay, I'll tell you. Cube root of 27 over 8 is 3 over 2, because 3 over 2 is 3 times 3 times 3 is 27. 2 times 2 times 2 is 8, so 27 over 8. Cube root of 27 is 3. Cube root of 8 is 2. There you go. So I just proved it, that you can do this sort of thing. Cube root of all that junk is the cube root of this junk over the cube root of that junk. Well, bonus here is that the cube root of A cubed is A. So we end up with R equals the cube root of A squared B over A. Now that's ugly, that's scary, that's terrible, but on the benefit here, we've got A on the bottom. So what do we do with R? Well, we multiply a term by R to get the next term. So the next term right here will be A times this crap. Well, A times this crap will just cancel the A's, and we've got nothing left but the crap. A squared B. So that's the second term. Whew. The third term, the nightmare begins, is going to be the second term, I'm going to write it out big here, times that crap, cube root A squared B. Oh my God. Over A. And that can somehow simplify, but I forget my rules, so honestly I forget how to do it. I don't know how to do it. I guess I could test it. Let's see. The cube root of 27 times the cube root of 8. I know that should equal 3 times 2 should equal 6. So is that the same as the cube root of 27 times 8? What's that? 56 and 160 is 216. Is that the same as this? Yeah, 8 times 8 is 64 times 8, no. 7 times 7 times 7, 6 times 6 times 6. Wait a minute. 6 times 6 times 6, that is. 6 times 6 is 36, times 6 is 216, so this does work. It passes the test. So that would be the cube root of a squared b over a, which equals the cube root of a 4b squared over a, which equals a times the cube root of a b squared over a, which simplifies to the cube root of a b squared. Cube root a b squared. That sucks so badly. That is just the worst time I've ever had doing math.